Hi guys, and welcome to this, our next video in our further maths course here on MaffsGuru.com or YouTube, depending on where you are watching. We're dealing with sine, cosine and tangent. Yes, I know your heart has missed a beat because you've already done this in year 9. And this is just another recap to allow us to scaffold all the stuff we're going to need for the next sections of this course. Now, if you are watching on YouTube, do me a favor, click subscribe and the little notification button, that little bell, and like this video. Greatly appreciated if you could do this. And why not head over to MaffsGuru.com, where all of these videos are loaded in a much better and searchable way, where the videos have downloadable notes, links to exam questions and solutions. They have time codes and so much more. It is free to subscribe over on MaffsGuru.com, and I promise you there is so much more to be able to get than I can do on YouTube. Now, we need to be able to know what it means by a trig identity. Okay, we need to know what it means by sine, cosine and tangent. We need to know that it only works for right angle triangles, and know that we can use these trigonometric ratios to find missing side lengths and missing angles. And this is much bigger than probably this introduction, and there are other videos coming up that help us use sine rules and cosine rules and trig, but we're going to zip on through. Now, obviously, this is a new section of work, but it's building on that previous stuff we've already done. So in the previous module or the previous chapter, if you are following on the Cambridge Further Maths textbook, had all that sort of lines and parallel lines and triangles and polygons and Pythag and trig. So if you haven't already watched those videos, why not go back? MaffsGuru.com, you can go previous and forward and go backwards through all the videos. YouTube, if you need to, just stop this one and load up the next one. But let's recap that trig stuff we've already been working on. Now remember, trigonometry only works on right-angled triangles, as does Pythagoras' theorem only work on right-angled triangles. Any other triangles, we use different rules, and there are videos coming up that will show us how to do that. Now, obviously, as I say here, we've met right-angled triangles before in Pythagoras' theorem, and we know that Pythagoras' theorem states that c squared was equal to a squared plus b squared. Yes, and what was c? Well, c was our longest length, otherwise known as our hypotenuse. And there we go, that is our value of c. Now, lots of people say to me, how do I know which side is the hypotenuse? And I always like to think to myself, well, if this is my right angle and I'm drawing it fairly bigger, I can turn that into an arrowhead, which points to my hypotenuse. And I'm going to spell that for you because lots of people think it's spelled like hippopotamus, and it really isn't. So there's my hypotenuse. The other two sides, when we use Pythag, don't really matter what we call them. If you remember, there was B and an A there, but we could equally have written that as A and B. It didn't matter. That was Pythag. Trigonometry is a little bit different because we have to label them different ways. And sadly, bye-bye A squared, B squared and C squared, and welcome back to something completely different. Now, first things first, as I've just said, this is always reference to a right angle triangle. We have to make sure that we only use this for right angle triangle. The next thing we need to know is one of the angles that we don't know. What do you mean by that? Well, we've already got this here as a right angle. So I'm going to call this angle here theta. Now, theta is the Greek letter used mainly in mathematics to stand for angles, but there are others. We can have alphas. And sometimes the textbook doesn't even use Greek letters, it just uses X's or it uses letters, all right? But for the moment, I'm just going to use theta because it's the one I'm most comfortable with and probably the one that you're going to see more of.